Hello everyone and welcome back. In the previous lesson, we briefly introduced MLOps as a concept. We now know that there are a lot more moving parts to think about when we want to train a simple model and serve it to our users. And we know that there is a lot of tools that are created to support these processes that we now call MLOps. Now, of course, covering all of these tools will be basically impossible, and you don't need to know all of these tools. The goal of this course is to introduce the two biggest tools that can create 90-95% of the pipelines that you will ever need: weights and biases and MLflow. When you learn new tools that potentially will be required by your company or a project in the future, you will only learn new concepts, syntax potentially created by these tools, but fundamental things that you will learn in this course will stay the same. So once you learn MLOps as a concept, it's just a matter of tooling that you will learn on top of that. But before we get started with coding, let's get a couple of things out of the way. I'm currently recording this course on the Windows platform. And why I'm saying this is these libraries that we will cover have different quirks and setup processes depending on the system that you're using. Some will be through GUI interface or the general graphical user interface, some through CMD, for example, Linux, and Mac, for example, will have CMD support, while, of course, Windows does not have that. And no matter which operating system you will have kind of a unique process of setting up the whole system. So please, before you continue to any further lessons after lesson 2, make sure that you can execute a simple script that imports weights and biases, and after that MLOps, or MLflow, sorry. So these libraries will be really necessary to get started and cover the whole course. And of course, please create weights and biases account. This is on you, so I'm going to walk you through step by step in the lesson 3 of this very section that you're currently listening into. But make sure that you have all of this set up before you continue. If you need help, please make sure to post comments in the comment section of machine learning area, and then me or some other instructor from the platform will get help and then resolve this as soon as possible. Okay, cool. For the rest of the setup, I'm currently using the editor called Cursor, which is an amazing editor. I switched to it recently because it's kind of AI powered, but you can use any IDE you want. You can use Visual Studio or you can use Cursor. Cursor is amazing because it does have support for code completion by AI, even better than, for example, GitHub Copilot. So it's on you what you will use. Okay, cool. Now that we got these couple of things out of the way, please make sure to download the code. And as always, you can find the link to GitHub. And as always, you can find the link to GitHub repository in the lesson 1 of each section. So go to the lesson 1 of each section. In the description, you will find the link to GitHub URL, where you can download, copy, or directly clone the repository locally, and you will get the code that you will follow through. For the lesson 2 that you're currently listening, we won't code anything basically. I want to walk you through a simple pipeline that will build together through the lesson, that will build together through section 1 of this course. Okay, so when you open the lesson 2 folder that under the section 1, you will have main.py and a couple of folders. Every single folder is descriptive by itself: clean data, download data, feature engineering, model training, and so on. Later down the section 1, we will learn that these folders are called components, and they're created for a library that we'll cover later on called MLflow. Now, when you open main.py, you'll see that these components are called or run by calling MLflow run and the name of the component or the folder that you name. So you can name with whatever you want. There is a rule that it can be as descriptive as possible, so please make sure to follow as closely as possible these rules, but you don't have to. You can name it as whatever convention you want. Cool. And of course, because this is a CMD command, you can go to your terminal and run it without running main.py script. We'll build this script later down the course, but just so you know, you can run each component individually through your terminal. When you enter each of these components, and I'm going to walk you through a simple one right now, let's call download data. You will have 3 files, conda.yaml, and YAML file is there to help us install the dependencies in a special environment, conda. So when you build MLflow pipelines, you can choose different environments that you can use, either Docker, conda, or some other like Kubernetes potentially. But we'll use conda because it's simplest to understand and is scalable as it gets. It has dependencies, it has channels, we will understand this later on, and of course a name that follows the name of your folder. So don't worry if you don't want to remember this right now. We'll go into really depth of building this YAML file later down the road. In the lesson 9, we'll actually learn about YAML files and its structure. So if you don't know how to build these files, don't worry. It's coming up. Then you have MLProject file, still YAML format, which is more for MLflow library to tell it to which file to run. And in this case, it's run.py. It has environment conda called conda.yaml, which is our other file, and the name that we'll give to this entry point. Run.py is a simple script. It has a couple of libraries, then 2 functions that download some data from an example URL. Now, of course, this is an example pipeline, and we won't run it right now. This is for you to just understand the briefly concept of building a simple component in a bigger pipeline. Okay, so every single component, if you open clean data, it will have this process. It has conda for installing the dependencies, MLProject to run this component itself, and then run.py to do some operations on top of your data in this case, or even train the full model. Now, every single component should be kind of individually separated. It does a single thing, downloads data, clean the data, feature engineer data, and stuff like that. It is there to prevent kind of a tangled bugs between these components, and we need to decouple the process as much as possible. And of course, it does require some thinking of what to log, what to prevent, what to save in the future, so that we prevent the future bugs if we have multiple components in our pipeline. So this is how you build a simple pipeline by running this in a concrete way that you want. Download data, clean, feature engineer, train, and some other deploy.
Now make sure to check out these videos on the right or the full course in the description to continue your learning, and I look forward to seeing you there.